You feel heat every single day, right? But have you ever really stopped to wonder how it's actually moving from one place to another? Turns out it's not just one thing. There are three totally different ways heat gets around, and believe it or not, you've probably seen all of them before you've even finished breakfast. So let's dive in.
Okay, just picture making breakfast. You've got eggs sizzling in a pan, maybe a kettle whistling for tea, and some toast popping up. Seems totally normal, yeah? Well, what if I told you that your kitchen is actually a perfect little physics laboratory in disguise? You know that feeling, right? You instinctively know not to grab that hot metal pan handle. But at the same time, you can feel that cozy warmth coming off the toaster from a foot away. It's the same energy. It's heat. But it's acting in two completely different ways. So how is that even possible?
All right, let's start with that sizzling pan. This first type of heat transfer is all about direct touch, and it's probably the one that makes the most sense to us. Scientists have a name for it: conduction.
So, when you look at the formal definition, the most important part to grab onto is that phrase, without movement of the substance. Think about it. The atoms in that metal pan aren't packing up and marching up the handle. Nope. They're just vibrating like crazy, bumping into their neighbors, and passing that energy along, one atom at a time. It's kind of like a tiny, invisible game of telephone.
So the bottom line is, conduction is a contact sport. For the heat to move, things have to be physically touching each other. Simple as that.
And this brings us right back to our breakfast. Heat from the stove gets the bottom of the pan all fired up, and that energy travels right up the solid metal, and bam, it conducts straight into your hand if you're not careful. This is exactly why solids are the main playground for conduction.
Okay, one down. Let's move on to our second breakfast hero, the boiling kettle. Now, the water inside isn't just heating up because the particles are bumping into each other. Oh no, something way more dynamic is happening here.
And this is pretty much the complete opposite of conduction. With convection, the key phrase is actual movement of particles. Here, the substance itself is physically moving around, carrying all that heat with it for the ride. This breaks it down perfectly. See, the water at the very bottom gets hot from the heating element. As it heats up, it expands, gets a little lighter, and starts to rise. Well, something has to fill that space, so the cooler, denser water at the top sinks down. Then it gets heated and rises, and this just keeps going, creating this amazing, rolling cycle that heats up all the water in the pot. And that is the key takeaway for convection. You can't get a convection cycle in a solid pan handle because those particles are all locked into place. But in liquids and gases, what scientists just call fluids, the particles are free to flow, and that's what makes these awesome heat currents possible. All right, and finally, we have the toaster. You can feel that warmth on your hands from a ways away, right? But stop and think about it for a sec. There's no solid object connecting you to those hot coils, and the air isn't swirling around like boiling water. So what's going on? Well, this is our third and maybe the most mysterious type of heat transfer.
This is called radiation. And for this one, you can pretty much forget about particles bumping or flowing. Radiation is just pure energy, traveling through space as waves, kind of like light, or even the signal to your radio.
And this is the part that just blows my mind. Conduction needs a solid. Convection needs a liquid or a gas. But radiation, it needs nothing. Absolutely nothing at all. It can travel through the complete and total emptiness of a vacuum.
I mean, this is the ultimate example, isn't it? The sun is 93 million miles away. And between us and the sun is just the vacuum of space. There's nothing there for heat to conduct or convect through. So the only reason we feel its warmth is because of radiation, which sends those energy waves hurling across the solar system straight into your kitchen.
So there you have it. We've seen all three in action and all before our first cup of coffee. Let's just put them all side by side to really lock in how different they are.
So let's break it down one last time. We've got our three contenders: conduction, convection, and radiation. What are the key differences we got to remember? This table just lays it all out so nicely. Conduction, yes, it needs a medium, and it's the king of solids. That's our hot pan handle. Convection, it also needs a medium, and it happens in fluids, liquids and gases, like our boiling water. And then there's radiation, the total outlier. It needs no medium at all and can travel right through a vacuum, giving us that warm glow from the toaster. So if you're going to sum it all up in the simplest way possible, conduction is the pan, convection is the kettle, and radiation is the toaster. Three totally normal objects, 3 fundamental laws of physics. Pretty cool, huh?
What's really incredible is that these 3 principles aren't just in your kitchen. They're literally running the world around you, from a campfire to the weather to the stars themselves. So the next time you feel a wave of warmth, stop for a second and ask yourself, is that a touch, a current, or a wave? Because once you start looking, you'll see this stuff everywhere.